Hey there, John here. Today we are continuing our deep dive into the advanced section of the Asus BIOS. Once again, we have a lot to cover, so let's jump right into it. Although I just want to start off by saying that I'm still navigating my way around creating videos. I just did a fabulous recording going through the things I wanted to cover today in the video, and then I realized that my streamer wasn't actually recording. So Murphy's Law would tell me that this is now going to be rife with errors, so we'll see how it goes. So first up, we're going to pick up where we left off, and that's we're going to jump in with the APM configuration, which stands for Advanced Power Management. The first item up here is ERP Ready. This entry allows the user to enable a super low power state when the system is in standby mode. This option will force the system to consume no more than 1 watt. I believe this is necessary for compliance with EU requirements. Then you have Energy Star Ready. Energy Star is a program run by the US EPA, and they have mandates on energy consumption. Selection of this option will force the system to comply with Energy Star requirements. Next up, if Energy Star isn't enough power savings for you, the California Energy Commission, or CEC, has some additional ideas on saving power. Enabling this option will force the system to comply with the regulations from the Golden State. Restore AC power loss. This entry allows the user to determine what happens to the system when the power is restored after an outage. In my case, I have it on power off. You could have it power on or the last state. My preference is if we have a power outage, system goes off, let me manually turn it back on so I can make sure everything starts up correctly. Then we got Power On by PCIe. This entry allows the user to enable the system to be woken from a sleep state through a message sent through the onboard LAN controller or through another LAN controller installed on the motherboard. Then we got Power On by RTC. This last entry allows the user to set an alarm to turn down the computer at a specified time in the future. If I enable this, you can see we have day, hour, minute, and second. For days, 0 means every day, whereas 1 means the first day of the month, 2 means the second day, and so on. Next up, we have the PCI subsystem settings. First up is above 4G decoding. Originally, this option existed for users with multiple GPUs with workstation-type machines or bit mining machines. The requirement is that you must have a 64-bit OS. However, with the availability of resizable bar, it appears that if the user wants to utilize SAM, which is AMD's Smart Access Memory version of resizable bar, the user needs to have this entry enabled. And if I ever am lucky enough to get a compatible GPU to plug into this machine, I'd like to give this a try and see how it works and do a video on that. Next up is SR-IOV support. This stands for Single Root I/O Virtualization. Quoting from Microsoft, the SR-IOV interface is an extension to the PCIe Express specification. SR-IOV allows a device, such as a network adapter, to separate access to its resources among various PCIe hardware functions. Next up, we have USB configuration. First, provides a little summary of what you have connected to your system. And then first up is legacy USB support. Enabling this option allows the BIOS to manage or handle USB devices. Disabled lets the operating system manage them. If disabled, the user may not be able to use the USB devices such as a mouse or a keyboard while in BIOS or in an older software mode. As an example, MS-DOS mode, if you have that in a virtual machine running on your system. Next up is XHCI handoff. If the user has an operating system that does not support XHCI, which stands for Extensible Host Controller Interface, it manages the USB 3.0 host controller. Enabling this option would allow the user to still be able to use USB 3.0 devices. Then we have we have USB device enable, allows for the motherboard USB ports to actually operate. And then you have the various individual ports, which allows the user to enable or disable specific ports. I'm not really sure why you would never want to have a USB port enabled, but the one example I was thinking of, again, thinking of about a corporate workstation, IT might want to prevent users from being able to plug in USB devices either to steal company data, potentially steal company data, or to unknowingly or knowingly download malware or other malicious software into the corporate environment. But in any event, you have the ability to turn them on or turn them off. Next up, we have the network stack configuration. If a user wants to be able to utilize something like network unlock, which is a feature in BitLocker, this option must be enabled. This would allow a network administrator to perform updates to a device that has a TPM plus PIN protecting it. An encrypted network key is stored on the server and would allow access to the system. When enabled, an additional option appears, allowing the user to enable the system to be woken up via IVP4 or IVPv6 PXE. PXE stands for Pre-Boot Execution Environment, which is a feature to allow a system to be booted up via a network command. Next up, we have HDD SSD Smart Information. Once again, SMART stands for the Self-Monitoring, Analysis, and Reporting Technology. This allows the BIOS to report errors encountered with hard disks during boot up. In this situation, there is no option as SMART is not available for NVMe Express devices, which is what I have is for my hard drive in this system. And then speaking of NVMe, we have the NVMe controller and drive information, which basically just provides information on the NVMe device that I have, and then also allows for some self-testing. Next up is AMD PBS. I can't be sure, but I think PBS stands for Plug and Play BIOS Specifications. I'd love to get confirmation on this from somebody who watches this. I found this reference in a very old Intel/Compaq document, and kudos to anybody who remembers the name Compaq. Since this section can include Thunderbolt, this particular motherboard does not have Thunderbolt connectivity, so those options aren't here. And Thunderbolt's an Intel standard. That's how I came up with my guess that this stands for Plug and Play BIOS support. But the only option we have here is Data Link Feature Exchange. This allows the user to enable or disable Data Link Feature Exchange. I'm grasping at straws in this one. I believe this entry relates to PCIe data transfers and managing the flow of data. A DLLP, which is a data link layer packet, can be identified as a data link feature exchange. You would enable this feature if the user needs the ability to do that type of data transfer, I guess. And then the last section we're going to cover today is AMD overclocking. This is going to be brief because most of the entries on here are repeats from what we saw in the AI tweaker. So rather than repeating and having duplicate material, I'll just let you know whether or not the option is in the AI tweaker section. But since these are the big boy settings, BIOS wants you to make sure you accept this so you know that you may fry out your components and void any warranties. So first up is the DDR and Infinity Fabric frequency timings. These are identical to the options that are in AI tweaker. Eco mode, that's not in AI tweaker, but it is a good feature to have in the overclocking section because Eco mode reduces the power consumption down to 45 watts. So if you wanted to do effective overclocking, obviously you want to have access to more than 45 watts, so you'd want this feature disabled. Then you got Precision Boost Overdrive, which is identical to the options that were presented in the AI tweaker section. Then you got LN2 mode, which LN2 stands for liquid nitrogen. If you enable this, the system provides additional stability at extreme cold temperatures. And then you got SoC voltage. This forces the CPU SoC components to run at maximum specified frequency. The trade-off for the better performance is increased power use. In order to enter a value, the next option of SoC Uncore OC mode must be enabled. So if I go to here and I enable this, and then I go back, then it allows me to input. We'll go back and disable this and continue on our way. And then the next two items are identical to AI Tweaker. VDDP voltage control is the same as the CLDO VDDP in AI Tweaker. And then the VDDG voltage control is the same as the VDDG in AI Tweaker. And then lastly, we have the NUMA nodes per socket. Options here are 0, 1, 2, and 4. NUMA stands for Non-Uniform Memory Access. It is a memory design used in multi-processing scenarios. It is an architecture that divides memory and processors into groups. NUMA is useful for particular types of work, such as servers. So we are going to call it there today. I hope you're continuing to find this information useful and educational. I know I have learned a ton as I was going through all of these. We have one more section to cover, which will be done in the next video, which is by far and away the largest section in this BIOS, not just the advanced, but the entire BIOS, and that's the AMD CBS. So I hope you stick around and look forward to seeing you in the next one. Wow, we've really covered a lot. I continue to be amazed by how many different options that are available to users. It is really incredible how all of our rigs are still able to run when there are so many variables that can be changed. I've really learned a lot going through all of this research to figure out what these entries are, and I hope that they've also been informative and educational for you. If you are finding these videos useful, please consider liking and subscribing, and I look forward to seeing you in the next one.